Greetings and welcome to Lecture 8.2, Properties of Radicals. We're going to start working with radicals in the simplified form, meaning it's the easiest to work with because anything and everything possible that you can take out of the radical, we have already done so, and then we have simplified any of the coefficients as much as possible. Consider the following two problems. We have the square root of 9 times 16, and if I multiply 9 times 16, it's the square root of 144, and the square root of 144 is 12. But if I do the square root of 9 times the square root of 16, square root of 9 is 3, square root of 16 is 4, 3 times 4 is 12. The two are equivalent. That gives us a little bit of power to simplify our radicals and make them a little bit smaller and easier to work with. Considering the previous example, this gives us our property for radicals, our first property for radicals. If x and y represent non-negative real numbers, then it is always true that the square root of x times y equals the square root of x times the square root of y. So using our new property, let's simplify the square root of 20. Square root of 20 we can write as the product of 4 and 5. And then from there, we can break it up as the square root of 4 times the square root of 5. Square root of 4 is 2, square root of 5 is irrational, so we can leave it as square root of 5. So our final simplified version of square root 20 is 2 square root 5. Let's see it again with another example. The square root of 75. Well, the square root of 75, I can write it as the square root of 3 times 25. The square root of, then I can break it apart using our property 1. It'd be the square root of 3 times the square root of 25. The square root of 25 is 5, so it gives me the square root of 3 times 5. But just like when we're working with variables, we do put the variable second. So if it was like x times 5, our final answer would be 5x. The same thing with radicals. So it would be 5 times square root of 3. Here's a little bit more complicated problem to simplify. So let's simplify square root of 25 x cubed. So the square root of 25x cubed will be the square root of 25 times the square root of x cubed. But I can break apart x cubed as in x squared times x. So the square root of 25 is just 5. The square root of x squared times x, this x squared, we can simplify by bringing it out of the radical, leaving me with x times square root of x. And our final would be 5x square roots of x. Now we are making an assumption with this problem. We are assuming that x is the positive number coming out of the radicand. Because of that, we're not going to stress the absolute value markers here to force it to be positive. We're just going to assume that it is positive. Let's try another problem. Simplify the square root of 18y to the 4th. Well, 18y to the 4th, I can write it as the square root of 2 times 9, which is the 3 squared. And then y to the 4th is really y squared squared, because 2 times 2 is 4. So if we do that, I have a square of a 3 and a square of a y squared. So both of these can come out of the radicand, giving me 3y squared, and the only thing left behind is the 2, so the 2 is under the square root sign. So 3y squared square root of 2. All of our previous examples we've worked with square roots, but this property 1, we can work with cube roots, fourth roots, and so on. So let's try it with a cubed root. The cube root of 24x cubed. Now you may need to we're going to break this apart, but you may need to prime factorize numbers So do remember your prime factorization rules. So the cube root of 24x cubed, we can break it apart into cube root of 24 times the cube root of x cubed. 24 breaks down into 2 times 2 times 2 times 3. And the x cubed is just sitting out there for a minute. But I have 3 2's, so that is the cubed root of 2 cubed times 3 times the cube root of x cubed. Because I have 3 2's underneath the radical, I can pull out that, so the cube root of 2 cubed is 2, but the 3 is left over, it's still sitting back, so that stays under the radical sign. And I have x cubed, the cube root of x cubed is x. So finally I just reorder it in a nice way, 2x times the cube root of 3. Now our second property of radicals has to do with division. Consider the following two problems. We have the square root of 64 over 16. Well, if I do this division, 16 goes into 64 4 times, so I have the square root of 4. Square root of 4 is 2. If I have the square root of 64 divided by the square root of 16, the square root of 64 is 8, and the square root of 64 is 4. 8 divided by 4 is 2. It's the same solution. So here's my property. Property 2 for radicals. If x and y represent non-negative real numbers and y is not 0, then it is always true that the square root of x over y equals the square root of x over the square root of y. Using our new property 2, let's simplify the square root of 49 over 81. Now let's take a look. I can't divide 81 into 49 and get a nice whole number or even a perfect square. So I am going to use property 2 to break it apart. So the square root of 49 over 81 becomes the square root of 49 over the square root of 81. The square root of 49 is really the square root of 7 squared. The square root of 81 is really the square root of 9 squared. The square root of 7 squared is 7. The square root of 9 squared is 9. So my final answer is 7/9. Consider to simplify the fourth root of 81 over 16. We're going to use the same property. First we're going to break it apart. The square root of the fourth root of 81 all over the fourth root of 16. I can rewrite 81 as 3 to the fourth. I can rewrite 16 as 2 to the fourth. Well, the fourth root cancels out the fourth power, leaving me 3. And again, for the denominator, the fourth root cancels out the fourth power, leaving me with 2. When you think about it, when you are taking a root of a power, it's like if I multiply by 2 and then divide by 2. I've done some operations, but they cancel each other out. For example, 3 times 2 is 6. 6 divided by 2 is 3. I get right back to my original number. My original number here is sitting here 3. So the fourth root cancels out the fourth power, leaving me with 3. Likewise, the fourth root cancels out this fourth power, and I leave with 2. In the other example, I have the square root cancels out the power of 2, leaving me with 7. So think about that if you ever get stuck on what comes out, what doesn't. Think about what can cancel each other out. Let's do another example, the square root of 50 over 49. Using property 2, we're going to break it apart. So I now have the square root of 50, which is really 25 times 2, all over the square root of 49. The square root of 25 times 2, I can break that apart using my property 1. So I have the square root of 25 times the square root of 2 all over the square root of 49. The square root of 25 is really the square root of 5 squared times square root of 2 all over square root of 7 squared. And again, this square root cancels out the power of 2. So 5 comes out of the radicand, leaving 5 square roots of 2 all over 7. Given the square root of 12x squared all over 25, let's use our properties to simplify. So all the steps are laid out for you, but let me walk you through them. The first, I'm going to use property 2 because I have a fraction, so I'm going to divvy up the fraction and give each of them their own square root. So the square root of 12x squared all over the square root of 25. The numerator, I have numbers and variables. I can break them apart using my property 1. So I have the square root of 12 times square root of x squared all over the square root of 25. 12 can be broken down as in 2 squared times 3. And 25 can be broken down to 5 squared. So 2 square roots, that gets canceled out, bringing out a 2. The x squared, the power gets canceled out, bringing out the x. So my final solution to 12x squared over 25, the square root of that, will be 2x times square root of 3 all over 5. For this video's class problem, I'd actually like you to work through 3 problems and then turn it in for the next class session. So we have, the first problem is the square root of 12 over 6. I want you to simplify that as much as possible. The second problem is 5 times square root of 18 all over 15. And the last problem is 6 plus the square root of 8 all over 2. Now you may need to go back to lecture video 8.2 to remember that, oh, you have to pull out not only do you have to simplify the radical, but the top, the numerator, you do need to find the GCF before you start reducing with the denominator. So I'll leave those to you, and please bring them in the back next class session. For one of your class problems, I'm going to show you an example very similar. So I have -1 plus the square root of 45 all over 2. The square root of 45 I can break down into 9 times 5, but 9 is the square root of 3. So I can simplify the radicand because I have a 3 squared. That can come out, and that leaves -1 plus 3 square roots of 5 all over 2. If the numerator had anything in common, I could pull out the GCF and then see if it can be reduced anymore. But this is as far as this expression can be simplified. Let's try 4 plus the square root of 36 all over 2. 4 plus the square root of 6 squared all over 2. But the square root of 6 squared is 6, so 4 plus 6 all over 2 is 10 over 2, which I can reduce that to 5. So you do want to continue these problems until you can reduce or simplify no longer. That's it for this part of the video. Until next time, be seeing you.